All right, number 2 off of quiz 5. In this problem, you're given that z this is a surface, x squared sine y, and you're given that x is equal to s squared t and y is equal to st. And you're supposed to find the partial of z with respect to s and partial of z with respect to t. So what you have here is an intermediate. You have, if you plug in s and t values, you will get then your x and y values, and you plug those x and y values in, you'll get a z. So if you think like a table, I'm just going to do 1 point. What if t was 0 and s was 1? Or s was, let's make it easy. Let's just put 0, 0. So in the 0, 0 is too boring. So let's put in 1 here. Then x would be 0, and y would be 0, and then z would be 0 times sine of 0, which is 0. So really, the surface is made by plotting this part, but you have these intermediate parameters which can represent time, two different kinds of time. One is t, one is s. So to find the partial of z with respect to s, there's 2 ways you can do this. The way that we focused on in class is using implicit differentiation. So the partial of z with respect to s is going to be product rule. So I have first times the derivative of the second, and I know you guys do this differently, but I just took the derivative of some function. Y is a function of s with respect to t. So I have to multiply, or s, this is the case, I don't know why I did s first, but I have to multiply, when I took the derivative of something involving a y, I have to multiply by the partial of y with respect to s. And then my second part of my product plus second times the derivative of the first, which is 2x. Now I just took the derivative of something involving the x, so I have to multiply by partial of x with respect to s. Now, the partial of y, so this is a box off. I call it boxing off this is important. I got to keep this. The partial of y with respect to s is just t. I got that from here. I'm going to call this number 2, from equation number 2. And number 1 gives me the partial of x with respect to s is equal to 2s times t. Those things, now everything that you have, equation 1, equation 2, and these partials get popped into the partial of z with respect to s. And so then I get partial of z with respect to s is going to be a nasty mess. It's going to be s squared t squared, that's the substitution for x, cosine y, so I'm going to get cosine st, and then partial of y with respect to s, which is just t, that's the first part, plus sine y, which is really, instead of y, I'm going to put st, times 2x, which is really 2 times s squared t, times partial of x with respect to s, which I have already here as 2st. If you're not asked to simplify it, don't. You're done. Now, how do you find partial of z with respect to t? I'm going through the whole thing, even though it's painful. Let's go do it. Same way. We take the partial of z with respect to t, and that's going to be same derivative. So I can literally just go back here and replace everywhere I have partial of y with respect to s with partial of y with respect to t. I'm not going to do that right now, but I'm just going to go through it one more time so you can see it. I get product rule, but instead of x, I'm going to have t here. Y with respect to s, I'm going to have partial of y with respect to t, and then sine of y times 2x partial of y with respect to t. And then I just pop everything in. And this is cosine. I know you're going to ask, what is that? It's cosine. I just started to write sine. And so partial of z with respect to t is a hot mess again. We're going to go back here. Well, I have it in front of me. Instead of x, I'm going to put s squared t squared cosine. Instead of y, I'm going to put st. Instead of partial of y with respect to t, I just computed that over here. Partial of y with respect to, oh, I haven't done it, so let's do it. Let's do it down here. Partial of x with respect to t is going to be s squared, and partial of y with respect to t is equal to s. And I just got that from the original definitions like I did before. I'm going through this part faster. So if I was going to put those in, I would have s here, and sine would be sine of st. And then here I have, instead of 2x, I'm going to have 2 times s squared t. And then partial of y with respect to t is just s. So I just substitute those all in. That's pretty much it. This is a straightforward just cranking through machines.